Alright guys, so I have been spending a whole lot of time trying to perfect AGC I/O with the monitor and NASSP. So I think I have everything working pretty well now. Get P63 started. So there's been several new additions since last time. Now, in addition to the tape meters and the throttle, the AGC, the monitor also keeps track of all of the CDU command counters. So the 5 channels for the IMU and the 2 channels for the rendezvous radar. It turns out that during descent, those things don't control the IMU or rendezvous radar, but rather the 3 IMU error signals control the FPGA error needles, and the 2 rendezvous radar CDU error counters control the crosshair pointer. So those are taken into account now. You can see the AGC null out its errors here. So we do a final alignment. I've also just spent a lot of time doing a whole lot of landings, so I know all the switches better. We'll be setting things up more correctly than in the first video. So the CDU output counters work now. So the AGC has control over these 3 needles and the crosshair pointer, or the cross pointer, which will become useful as we come up to landing. It'll show the horizontal and vertical velocity. The other big thing that I added is the hand controller. So I have a rotational hand controller here, the ACA, the Attitude Control Assembly. We load rad modes. Go 2 and turn off minimum impulse. So the hand controller was kind of complicated to add. It goes into the AGC through the crazy analog digital converter and the interface modules from the resolvers. It also shows up in channel 31. It shows up in channel 31 if the hand controller is sufficiently deflected. And those bits in channel 31, if any of them become set, if the AGC has requested it, they can trigger an interrupt, hand direct. And so I had to get all of that working for the hand controller to properly work. So what I ended up doing was generalizing the logic that I made to inject DISC key presses. And so now I can use that same logic to inject any type of interrupt and not just the DISC key press interrupt. So that can now inject hand erupts. I don't have it running right now, but it can inject down erupts. And the other thing that is needed for a landing is descent engine command over on. I forgot to switch last time. The other thing that's needed for a landing is mark erupt or keyerupt 2, which is the interrupt that the nav DISC uses in the command module. But for the lunar module, it's just other switches. It's called mark erupt because it's used for marking things, but also it's used for the ROD or rate of descent switches, which are needed for P66. So last time I just let the AGC do a completely automatic landing with no inputs from me. This time my plan is to redesignate in P64 to get to a different area than the AGC is targeting right off the bat, and then go into manual control in P66 and fly the landing that way. So far, not a lot of stuff's different. The FPGA needles obviously are going how well we're pointed the way that the AGC wants us to be pointed. The crosshair pointer is reading off scale low here because we're moving so fast, and the horizontal is just going to kind of bounce back and forth, more or less following what the FPGA is doing. The next difference from last time is that at T plus PDI plus 3 minutes 30 seconds, I'm going to use my hand controller to roll over like I'm supposed to, and get those radar measurements incorporated earlier, around the 5 minute mark. So this is much more sort of what would be expected for an Apollo 11 landing. Much more accurate. Also accurate to 11 is that the monitor is also now capable of injecting T-loss. So once every, I think it's, what did I say? It's like once every 640 1 megahertz clocks, it injects 2 memory cycle times worth of stops, which is exactly what you would get with 2 misbehaving CDU counters for the rendezvous radar, because my rendezvous radar is an off track right now. They had it in slew. So I have the 15% T-loss going on my AGC right now. So we will probably see some alarms during descent. You won't see any alarms until comp-acti is solidly on. You can more or less use comp-acti as a CPU load indicator. So we've got a decent amount of off time right now, but that's going to start building up towards the end of P63, and especially in P64. So 3 minutes 30 seconds. Using my ACA to start rolling the LEM over. I can look out the window while we do this. Watch the lunar surface go by. So the other big difference from last time I was having problems with random attitude excursions on the LEM, sometimes causing me to crash into the surface. I had workarounds in place to make the CDU counters not make the RCS fire like mad. Lots of sort of weird behavior, and I ended up tracking it down. I don't know why, but I know that my peripheral instructions, writing memory inside the AGC, are a little bit buggy. And it took me a couple of days of debugging, and I still don't know what's going on. I've watched the traces in the logic analyzer. It seems fine, but I'll just get random restarts, and sometimes the CDU counters will be corrupted, sometimes the landing radar will be corrupted. It's all very catastrophic to actually achieving a good landing. And so what I'm doing now, as sort of a workaround to this problem, is I am using simulated erasable instead of AGC internal erasable instead of real erasable. And what that lets me do is, instead of using a peripheral instruction to poke a value inside the AGC, I instead can just poke the memory inside the FPGA and just give the AGC the updated value when it asks for it. So it's much more seamless. All of the problems magically disappear when I do that. So that's probably how we're going to end up operating, is through simulated erasable. This also lets us, it puts the AGC into a lower power state, so it doesn't heat up quite as much while we're doing the demonstrations. lets us not be exercising the current switch module when we can't watch it with the full monitor alarm panel. And you know, we can do all the other demonstrations with internal erasable when we have the monitor up before we get into NASSP here. But I think unless I can root cause the problems in the next few days, we'll probably just be flying like this with simulated erasable. Alright, so we're coming up 6.5 minutes, so we're about to throttle down. P63 load is pretty high, but not quite close enough to causing an alarm with the 1668 up here. So we should be throttling down about 6:45. Yeah. Okay. Like I said, everything basically works and it is reliable. The only caveat to that is that I do have to have good frame rate to get all the updates for the radar on time in particular. And I have good frame rate in this screen, I have good frame rate while looking out the window, but there is a decent bit of lag in an ASSP when you change views. And so if I were to go from this screen to looking out the window, I might get a bad landing radar reading, which would send the LEM off sort of in a crazy angle. And in late P63, that's after the throttle down, that's pretty catastrophic. That can just lead to a crash if that happens once. So I'm just going to stay in this view until we get into P64 and pitch forward, and then it's safe for me to look out the window. It's just late P63s. And we'll be getting into P64 at the 1 minute mark here. Load on the computer still seems fine. I don't really seem to be in any danger of getting out of program at the moment, but that's probably going to change as soon as I allow redesignation in P64. So P64 coming up. Here it is. Okay, I'm going to put landing antenna to hover. Now let's take a look out the lead. Okay, so load right now is it's pretty high but acceptable. As soon as I hit proceed to allow redesignations, it's going to get too much for the AGC. So while the AGC struggles here, I'm going to be shooting for this little light area here for the landing, which is a little bit beyond where the AGC is taking us right now. So I'm going to redesignate forward a couple times, and then I'll redesignate off to the side here in just a little bit. Okay. To the left a little bit. There it goes. It takes a little bit for the LEM to respond to inputs. There's the first program alarm. 1202. Okay, so we're heading towards 41. We're still a little bit shy of the light area, so I'm going to push it forward again a little bit. Program alarm. Thunder 1202. 30. Another program alarm. The AGC is really angry if you have 15% T-loss in P64. 25. Yeah, so it looks like we're coming in, let's set it to the right a little bit again, but we're coming in more or less right where I was hoping. Let this, now I'm going to go ahead and kick it into attitude hold and hit the ROD switch. So at this point, P66 is much less computationally intensive than P64. So I'm just going to start bringing this down, nulling out the horizontal velocities here. Okay, level off. drift to the right a little bit. 64 feet. 4 down. Slow the rate of descent. Okay, picking up dust. Okay, contact light. Shut down engine. ACA out of detent. Stops the RCS. Descent override off. Engine arm off. Let's see, how many alarms did I get at the end there? I wasn't really paying attention. Okay, 2 more 1202s. Yeah, so not particularly happy AGC, but still perfectly capable of doing a landing. It was a little bit jerky there. It's not quite as jerky if I don't have the TLS on. It's definitely an effect of the overload. So now that I'm on the surface, last time I did a P68, which calculated my landing site coordinates as the surface stay program. This time, instead of staying on the surface, I'll decide that no stay, we gotta get out of here. So things auto, abort stage, engine arm ascent, and then take a look at the moon and maybe catch a glimpse of our descent stage. Yeah, there he is. As we get out of here, so this will take us all the way back to orbit. It shoots for like a 15-kilometer periloon and 60-kilometer apiloon or so. It takes a while to get there, so I'm just gonna go ahead and stop this scenario. But yeah, that's where I am on the landing. I think pretty much everything is working.